Tonight's video looks at air masses, fronts, and areas of high and low pressure. So we're going to start with air masses, work our way to fronts, which is a boundary between an air mass, and finish up with pressure. So first thing we're going to talk about is this idea of something called an air mass. And an air mass is a large body of air, we are talking thousands of miles across, that has similar properties to the surface it formed over. So it's a large body of air with similar properties to the surface it formed over. And there are two ways to describe an air mass. We describe it based on its location. It can be either continental, sea, or maritime. Maritime meaning formed over the water, M. And we can also describe the temperature of the air mass. We can say that it's either polar, which we abbreviate with a capital P for an air mass, or tropical, T. So location, continental air masses are going to be dry, right? They form over land. Maritime will be more humid, forming over water. Air masses can be either polar, meaning they would be cold, or tropical, meaning they will be warmer. This will make a little bit more sense with a picture. So here are the air masses over North America. All right, you can see farther north you have maritime polar over here, forming over the water and in a cold place. Continental polar, cold and dry. Maritime tropical, hot and humid. And then continental tropical, hot and dry. All right, this A is Arctic. We don't see that very often coming all the way down to the U.S., but it was already part of the picture. So we're only going to worry about these ones down in here. So these air masses are huge. They might be thousands of miles across, and when they meet each other, they don't mix very well right away. They kind of bounce into each other and form a boundary between them. And that boundary is called a front. So a front is the boundary between two air masses. Eventually the air masses will mix together, but at the beginning the densities of the different air is so different that the air masses almost they don't bounce off each other, but they just kind of hit each other and stop without mixing. And these fronts usually result in precipitation. And we've got a couple kinds of fronts we're going to talk about quickly. Our first type of front is what's called a warm front. And this is where warm air pushes over colder air. All right, and this results in days of steady rain. All right. The symbol is these little round shaped things. The line shows the actual place where the front is, and then the circles show which way the front is moving. So the warm air is behind, the cold air is above. Make sure you get a sketch of this symbol in your notes. And we'll take a look at this animation quickly that kind of shows how this works. So in our warm front, as you can see, the warm air pushes in and is pushing the cold air forward. As this warm air hits the cold air, it goes up, cools because it's going up, and you're going to get condensation forming clouds. So earlier on, we're going to have a bunch of water dump out and form nimbostratus clouds. Then we'll get stratus clouds, cirrostratus, and then cirrus clouds way out in front of our warm front. So that's a warm front, warm air pushing in up and over the cold air. All right, we'll come back and look at cold front in a second. So our cold front means that cold air is going to advance behind and wedge itself under warm air. So a cold front means that cold air is pushing in. So as you can tell, the fronts are named for the air that's pushing in. So this is cold air pushes under warmer air. Right? And as a result, the warm air is pushed up rapidly and we get lots of thunderstorms. So a cold front tends to get very heavy, quick rain rather than long, steady rain. All this water is supposed to just pushing up gently, like in the warm front, gets shot straight up in the air, and it all evaporates quickly. This symbol is the triangles. Right? Again, the triangles point towards the direction the front is moving. And so to look at that, you can see here the cold air is pushing in and the warm air just gets pushed almost straight up. So all that moisture gets dumped out in one spot, and that makes a very, very heavy precipitation area right at the boundary of the front. Those are our two main fronts. We also have what's called an occluded front. And this is where a cold front catches a warm front. And then it traps the warm air above the surface. Alright, these aren't as common. Their symbol is both symbols combined on the same side because this front is still moving. So you've got the cold front symbol and the warm front symbol. So this warm air gets trapped up above the surface, and we're going to have some rain there until this air runs out of water vapor. So again, these are not super common. Just know that an occluded front brings rain, and it's still moving, and it's got both symbols on the same side. Our last front is a stationary front. As you might have guessed, this doesn't move, and this occurs, it's a boundary between air masses that isn't moving. So it's a boundary that doesn't move, and you may get precipitation for several days. And its symbol has the alternating air masses. So the occluded front had both symbols, but they were on the same side because the occluded front was moving. A stationary front isn't going anywhere, so you've got one symbol on one side, one symbol on the other, and then back on the other side. And that's how we can tell the difference between a stationary front and an occluded front. So those are our fronts. And the last thing we want to talk about is areas of high and low pressure. And so these areas can be caused by temperature differences or by fronts moving along the surface. And so as the fronts move, features like mountains, the front can almost, if you think about like a piece of string moving across a table, if there was something sticking up off the table, your piece of string would get caught and start to twist. And in the same way, this front can get caught and start to twist. And this spiraling action can create areas of high and low pressure. So for our notes, we'll say these form from a variety of sources. All right, there's a couple other reasons that are pretty complex, but for us, we'll just need to know that they can exist. So it forms from a variety of sources, and the spiraling wind action creates high and low pressure areas. So in a high pressure area, you've got air coming down from high in the atmosphere. And as a result, it tends to be very dry. Right? This is good weather because this air pushing down isn't really bringing any moisture with it. It starts out colder up here, so as it comes down and heats up, its relative humidity actually gets lower. Right? Temperature goes up, relative humidity goes down. So we get good weather at our high pressure area. On the other hand, at a low pressure area, air comes in and rises, and we get clouds and precipitation. Right? Winds come into the low pressure area and come up, and that's why we get lots of clouds here. So we have a good way to remember this, and that is that high pressure equals happy weather, right? H for H, and that low pressure equals lousy weather. We saw that high pressure brought good weather because we had high pressure. The air was coming down to the Earth's surface, right, bringing with it dry air. Whereas in low pressure areas, we have air coming up and away, condensation occurring, lots of clouds, and we're going to get lots of rain there. So make sure you do a summary. There's a lot to these notes. Make sure you have a good summary. Make sure you fill out the survey. That's really important because there's a couple questions I want to make sure we're all on the same page. Do the summary first. Make sure you can think about it and explain this stuff. Then go do the survey, and we will do more stuff at this in class tomorrow and Thursday.